So hopefully the warm-up at the top of the page wasn't anything terrible. Hopefully you kind of remember it from chapter 1. What you wanted to do was to isolate your variable. So you were going to get the variable on one side and the number on the other. That would give you a point. That point represented a circle on our number line. If it was less than or equal to, then that circle was closed. If there was no equal to, then that circle was open. That represented that that point was or was not included in the solution. So out of 1, 2, and 3, 13 is not included in that solution. And then in 1 and 3, the -3 and the 5/4 are included. So what we would do then is shade the number line. Anywhere you had shading represented a solution. Anywhere you had shading represented a solution. So we're going to talk and focus a lot in this unit on what is or isn't a solution. We're going to focus a lot on what is or isn't a solution. So I'm going to do the next part in lots of fun colors so that it's easier to identify as we work through that. So we're going to start by graphing the line y equals 2x plus 3. So that has a y-intercept of 3. So you're going to plot your point at +3. And then you're going to apply your slope. So the slope is +2. So you're going to go up 2 over 1, up 2 over 1. Or down to left 1, down to left 1, down to left 1. Okay, at that point, you are going to plot all of the individual points. So let's start with that first point. So I'm going to make my first point red. So that point is going to be at -2, -3. That second point is going to be in orange at -2, -1. Then I have a point at -1, -1. A point at -1, +5. Zero, 4. Zero, 5. One, 6. And then 2, 3. And 2, 7. So then what we got to do is talk about each of those points we just plotted and where they lie on the graph with respect to the line y equals 2x plus 3. So you want to identify each of those points as above, below, or on the line. So we're going above, below, or on the line. So we have several points above, several points below, and 2 points on. What we want to do now is determine, okay, are the points above, below, or on the line, or all of them, none of them? What ones count as solutions? So the question is, which points make that statement y is greater than 2x plus 3 true? What points make that statement true? Okay? So -2, -1 you said? Okay. And then what other point?
2 and 7.
Okay. So let's look and see if that's true. So those 2 points are the points that are on the line, right? They're both labeled as O. So what we're going to do is try plugging in points on the line. So let's just plug in the -2, -1. So -2 is x, -1 is y. So we're going to plug -2 in for x and -1 in for y. And when I plug them in, I get -1 is greater than -1. So this is where it becomes a little bit unique. Is -1 greater than -1? No. So now that's where this topic comes into play, because this is not an equals. The points on the line no longer have to be solutions. So the points on the line in this case are not solutions. So the points on the line are not solutions to the inequality. So now we need to compare a point below. So that would be -2, -3. And we want to compare it to a point above. So we could use the 0.16. So is -3 bigger than -1? No. So below doesn't work. Is 6 bigger than 5? So what that means is all the points above the graph work. So what we're going to get towards is shading our graphs. So again, we are talking about inequalities and what makes them true. So a solution to an inequality is a point on that graph that makes the inequality true. A solution to an inequality is a point on the graph that makes the inequality true. When we graph, we are now going to graph with shading and dashed and solid lines. So in that last example, the line I graphed would not have been solid because it was not equal to. It would have been dashed. The line would have been dashed. Yes. everything we graph right now is going to be a line. Everything we graph right now is going to be a line. So we're going to graph linear inequalities. So everything we did previously to this point has been lines as well. All we're doing now is adding shading. So you start with your y-intercept. So you start at 0, 4. Apply your slope. So slope is 2. So you go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Once you run out of ups, you can go down to left 1, down to left 1, down to left 1, etc. Then you want to look at the inequality and compare it to the formula you just talked about on the front, which is, okay, this is greater than or equal to, so that tells me that it is above and solid. So you're looking at the inequality and determining where do you shade and how do you connect your dots. So I connect all my dots because it is solid, and I shade above because it is greater than. So then the question is, give me a point that is a solution. What points are solutions? In this case, a solution to this inequality could be on the line or above. So any point on or above. So like 0, 4. Negative 6, 0. There are an infinite number of possible answers. 0, 9. You can go on and on and on and on and on and on. All you need to do is give me one. If those are the points that are solutions, what is a point that would not be a solution? What is a point that would be? Go ahead, Anthony. Okay, anything below. So what's an actual point below my line?
1, 1.
1, 1. Perfect. So 1, 1. 0, 0. Negative 10. Positive 10. Negative 10. Okay, where does that point fall on the graph? The follow-up answer was below. So a point fell below the line that was not true. Okay, same idea. If you're going to graph y less than 1/2 x plus 3, on what side would we shade? Above or below? Y is less than. So, perfect. We're shading below. Is my line solid or dashed? Is there an equal to? My y-intercept is at 3. So you start at 3. And then go up 1, go over 2, up 1, go over 2, so on and so forth. And then you follow your rule. First solid, first dash. So in this case, my line is dashed. So I do not connect my points as a whole line. Do not connect your points as a whole line. And then you shade below. Make 3 points that would be solutions. So again, you can pick any points in the shading But this time you cannot pick points on the line. So they have to be in the shading, but not on the line. True. All right, what happens in number one is in what we call standard form. You cannot graph a linear inequality from standard form because you don't know what could happen to the inequality when you solve for y. So you need to get from standard to slope intercept. You can or cannot reduce the fraction of the slope. It doesn't matter. It'll work either way. Then you again look at the inequality. This is less than. So the inequality is less than. So that means that you are going to be dashed and below. Y-intercept is 2. You have to always give me at least 3 points. The way I can see your dashed versus solid. And above versus below. And then the last one, y-intercept at 5. This one has a negative slope. It is going to be solid and above. I'm trying to do what I did, which is to shade below. Okay. Questions? Concerns? Pretty easy. Just looking it back after this one. All right.